And are we live? Did it do the 30 seconds already?
I have no idea.
Yeah,
On,
looks like we're
on,
live.
on my screen, it says live since 29, 30 seconds, but I haven't
Oh
heard any
well.
music, but
I
I
usually
don't know.
I must have undone something. Usually there's a 30-second bumper. Doesn't matter. We're here. That's all that matters. Um, I am so excited because normally the 30 seconds is just for me to to get ready, but what who needs to get ready? It is the 5th of August, Wednesday, and I'm sat not in person, sadly, but I'm here with my friend Martin Lippert. Um, I guess I don't know. Would I call you the lead of the Spring Tools effort these days, or what is
Yeah,
your
that's fine. That
title?
that that works. Yeah.
Um, I wonder how long your predecessor was here. I have to think you've been doing it longer at this point, a
I
good
so
good deal longer.
I I joined the team in 2010.
Yikes! Yeah,
So
and so Christian. Well, I mean, 10 years before 2010 was 2000. There was no spring, so
yeah,
certainly,
probably.
yeah,
Yeah,
certainly you've been doing
I'm
it as
here for
long as,
long.
yeah.
Maybe
Um,
even twice as long.
yeah. Well, anyway, I have. You are certainly the one I attribute with having taken, uh, you know, like the Phoenix. You've taken the tooling story from a place where it was good and then made it, just this incredibly amazing win for so many people via the effort, which I thought, if I'm honest with you, between you and me, at the very beginning, I thought it was like a little uh risky, to spend this time to go to Visual Studio Code at the time
Yeah.
seemed like a,
Yeah. It
you
was.
know, but
It
it's
was actually. Yeah.
yeah, but it turned out to be such a masterful like decision there. Oh goodness. Um, and so I guess you preside over all the because writing code is one thing, but writing code with the support of tools is yet another. And I think a lot of people when they think of Spring and they think of uh, how what can I write in my code, but not how I write that code. And actually, I think how I write that code is almost as important, right? Because we're better for our tools. So
Absolutely. Yeah.
you work on the Visual Studio Code support, the Eclipse support, and what else?
Yeah, with the Visual Studio Code support, we get this nice benefit of that this also works in Cursor or in anti-gravity or in code spaces and all the other environments that actually kind
Yep.
of are built on these Visual Studio Code foundation. So in theory, you can say, hey, we built the tools for Eclipse, for VS Code, for Cursor, for
Right.
anti-gravity, for code spaces, for Eclipse
Right.
Sphere, and for more, right? So it's kind of a giant. So that's, I think, one of the great outcomes of the move that we did back then to re-architect everything and build it on top of the language server protocol, language servers, and then VS shipping the stuff of VS Code. That now, whenever there's new IDE coming along that builds on top of VS Code, we are already there, right? We're already, yeah, the Spring tools,
Right.
you can use it because the extension is already there, it works. So that's, I think,
Well, don't
that's
forget about
it's a very, very good position to be in these days. So I enjoy that.
don't don't, don't forget about the Lord's editing environment, Emacs, right? Which you
Of
also
course.
support by extension with your
Yeah.
language server support. Um, I don't think that's officially supported, but it can be made to be done because it's just a language
Yeah.
server, and
Yeah.
uh, and
Yeah.
also NeoVim, Vim, which is
Of course.
pretty amazing. That your initial gamble on supporting the language server stuff would take you to basically every corner of the editor world. So I guess we should step back a second. What is all this stuff that we're talking about here? What is the when we talk about Eclipse? That's an IDE. Um, there might be people who don't know what that is. There's a lot of young people who maybe don't know what Eclipse is, but they will know what Visual Studio Code is. Can you explain?
The history? Yeah, of course, of course.
Or
Yeah,
just
it's
briefly, yeah, yeah.
yeah, I think it goes back to probably the early 2000s when kind of there was a kind of a team at IBM that built a kind of Visual Studio, not Visual Studio, kind of, it was called Visual Age for Smalltalk back then.
Right.
And then that was kind of built an IDE in Smalltalk for Smalltalk. And then they built Visual Age for Java. There was kind of a Java IDE built in Smalltalk, but for Java. And then they decided to think about how can we build actually an IDE in Java for Java developers and for
Right.
other developers as well. Right? And then they built these kind of new and fancy IDE that was extensible and people can plug in extensions in, and they called it Eclipse and made it open source, I think in 2001 or so. And that was kind of the point in time where people were able to really super easily extend an existing IDE with additional tooling, right? Additional tooling for additional languages, additional tooling for all kinds of stuff, because it was all open, and there were so many APIs and extension points that you can plug into that the team, Christian Dupuy, you mentioned him, and I think it was Thorsten Jürgeleit back then, they decided to say, hey, there's Spring, and we want to help Spring developers. And you remember these kind of people hacking Spring XML configuration files with really kind of, with a text editor hacking XML, that's not a lot of fun. So they did a lot of work to kind of do these auto completion and validations from a Spring perspective for all these Spring config files back then in Eclipse, because it was super easy to do it back then. And then that grew over time. It was called the Spring IDE project, and then it supported more and more Spring projects. So basically helping you to make it easy for you to develop stuff in your favorite IDE. And back then, Eclipse was the favorite IDE and the dominant IDE.
Right. For good reason. It's really good.
Yeah. And then kind of there was always kind of these kind of IntelliJ coming along, and kind of this little battle, and who's better and whatever over time. But I think that was kind of the Eclipse story back then, to make it really, really, really short and brief. And the Spring extension was kind of one of the major extensions back then.
Yeah, and my experience of all of this was coming into it from the 90s. Every tool that people used was expensive. So I'm talking like thousands of dollars, even in the 90s, for if you wanted to buy Visual Studio, the full thing, or JBuilder.
There was this kind of, I think it was kind of the Sun Java workshop thing,
right?
I think was really the first IDE-like thing that they tried to build in Java to demonstrate you can do things like that in Java, but it was very, very limited. And I think at the same time when Eclipse kind of got built, there was this movement around JUnit and refactoring tools. And those were kind of the things that they built into the Eclipse IDE right from the start as well.
Right.
These re-automating, renaming, and extract method and things like that. And that was a kind of a giant step forward compared to all the other IDEs that exist back then. That
Huge.
were just purely kind of doing, let's say, syntax highlighting and auto completion.
Right. And I also remember it being, I don't know if this makes sense. I don't know if my recollection of it is different from what was, but I remember Eclipse feeling very sort of code first. You wrote code, and yes, there were dialogues here and there were things you could do, but it was very much editor first, whereas you couldn't help but feeling swamped by wizards and panels and modals and all that stuff in some of these other tools. I mean, Visual Studio, after all, is the reason they call it Visual Studio is because you were meant to drag and drop your programs together, right? You had a visual canvas, and so
which is a totally different thing than Visual Studio Code, right?
Yeah. Like, Visual Studio Code is not visual at all. It's just code, really. But that's what I'm saying. You come from that world of like everything looks like a Visual Studio Code, Visual Studio from the 90s, and you've got JBuilder, JDeveloper, even Forte, which became NetBeans. Even that, now NetBeans is a fine product, obviously, in a project. But in the very beginning, I remember it being like 10 different panels, and then here's your little buffer for editing code, and
Yeah.
it just felt second class. And then you get to Eclipse, and it was this very sort of, here's your text editor, and it'll, it's open source, and so we can add, any project can add support for what they want there, and it's I just remember feeling very sort of grateful that this community was going to be able to grow independent of any one particular vendor. And back then I was worried about Microsoft, right? So yeah, that was a huge thing.
Yeah.
And it's still super popular, but Visual
Yeah.
Studio, well, I mean, it's not the same as it was in 2002 or whatever, but
Yeah.
or even 2007, but Visual Studio Code, oh my goodness, is phenomenal. Everything.
Yeah.
It seems like everybody's. I ask people at conferences all the time. I ask them, what IDs are you using? And I remember there was a time when it was mostly Eclipse, and I remember watching as that number gave way increasingly to IntelliJ, and now I'm seeing, there's 5 people and if I'm speaking to a customer and there's, 50 people, maybe there's 5 people or 10 people using Visual Studio Code. It's starting to grow again. It's
Yeah.
very, very interesting.
Not sure if you know that, but behind the scenes, the team that is building VS Code, or the team that initially built VS Code,
Right.
is to a large degree the part of the team that initially built Eclipse.
Yeah, I did know that. Yeah. Can you talk about that? That's cool.
It's kind of the Eclipse team was kind of, I think, worldwide distributed, but there was one team in Zurich led by Eric Gamma back then.
Right. The Eric Gamma, yeah.
The Eric Gamma, like Gang of Four, design patterns, JUnit,
Right.
Inventor, and things like that, right? One of the greatest of all time, right? So he led the team in Zurich, and I think they mostly focused on the Java developer experience in Eclipse, but also probably designed a lot of the underpinnings of that as well. And then he moved over to Microsoft, and I think some colleagues with him, and they built the first versions, and I think the first editor built on these HTML technology, and then that grew into Visual Studio Code actually. And I think probably the second, third, fourth time that team built the best IDE in the world, which is pretty impressive and amazing.
Pretty impressive, yeah. It's expertise begets expertise. And so Visual Studio Code, I don't use it that much, but I'm old and I'm just stuck in my ways. I'm sure it's fine. I do every now and then use Eclipse, and you and I were talking about WTP the other day, Web Tools platform, right? And I've been thinking about that a little bit here, because that's one of those things where it was not possible to do work without it, right? It was and I
At least
remember
not for web projects, right?
Yeah, I mean, basically, if you wanted to do enterprise Java, whatever that means, you needed a way to do deployments and cycle your server. And so every vendor built a plugin to support cycling their server, to integrate with it. Some even had WebLogic, BEA, before Oracle bought it. BEA had a BEA. Was it like Studio or something? It was like, I forget, but it was they had a custom thing for their WebLogic app server, and then I think that became just a thing that was possible with WTP. But before that, it was up to each vendor to ship these custom plugins, and they all behaved inconsistently, and suddenly here comes WTP, and now it's like, oh, I can deploy this standard thing in a standard way in my IDE, because of WTP. That's a huge thing. It's a small thing.
Yeah, it was back then. Yeah, absolutely.
I just from within Eclipse, it just felt like, okay, start, stop, cycle, but the amount of integration to make it work across all these otherwise incompatible, because there's nothing in the Java EE standard about how to start and stop and deploy or even better, hot deploy an application,
Yeah.
I wonder how many people worked on just WTP, just by itself, just that little panel, this little
Yeah,
panel in Eclipse.
I don't know, but I think it was a kind of significant team at IBM back then. Yeah.
Oh, I mean, I'm sure, but I mean, yes, of course. But what I meant was across all the vendors and all the
Oh, you mean yeah.
people building application server integrations, JBoss, IBM, and BEA, and Oracle at the same time, and
Yeah.
Sun, and there's even you could do WTP for like FTP servers too. It wasn't just app servers. If it was like any deployment target, right? Like, um, so yeah, there's a good many things. I mean, just anyway, phenomenal, 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 and it had its that experience. Um, Originally the goal was, I don't think we ever delivered it, but the original goal was to have the ability to live reload plugins. So they created this thing called OSGI, right? And the idea was you could deploy because having a bunch of plugins cohabitating in the same process space was never easy. So they created this, from my experience anyway, they had OSGI. Can you talk about that for a second? Because I think that's
Yeah, I
interesting.
think, yeah, of course. In Eclipse, I think in Eclipse version 1, version 2,
Yeah.
they had this ability to plug in extensions, and they have built their own plugin system for that, their own class loaders, and loading these additional plugins into the JVM and things like that. They're basically their own system. And
Right.
I think they tried to kind of enhance that a little bit and improve that, and then they figured out that there is actually something like that existing in the space of Java, which was called OSGI. And I think OSGI itself was kind of a description, specification, and implementation that was really meant for more embedded systems, long-living embedded systems, where you want to have these kind of very isolated environments and isolated modules, and you clearly describe the dependencies between the modules, with what package depends on what other package and things like that. And that was very successful, I think, in that space. And then they took that and improved that and kind of made that a little bit kind of compatible and closer to the existing Eclipse plugin system that was existing back then for the older versions. And then they shipped Eclipse based on this, let's say, new version of OSGI as the underlying module system. Which was kind of a giant step forward.
Yeah.
Because they were able to do these kind of things, like you can define my extension uses, I don't know, Apache Commons version 1, and the other plugin uses Apache Commons version 2, and the next plugin uses Apache Commons version 3, and they can all coexist in the same JVM and being wired to the exact plugin, so that they are all able to use these different versions of the same library at the same time without running into conflicts, which was not really possible without these module systems. Right. And what's the sequence on the class path, which class gets loaded, and things like that.
Right. It created this isolation that was very useful at runtime.
Yeah. And in addition to that, OSGI had this ability from the embedded space to dynamically load and unload these extensions or these plugins or these modules.
Right.
Called OSGI bundles. It was really, really meant for these kind of embedded space, and they sort of inherited that because they were building on this runtime. So the runtime had the ability, but the whole system around it was not really the whole Eclipse extension points and all these.
Right.
The IDE was not really built from the ground up with these dynamic features in mind, like while you're running, you are plugging things in, you're dragging things out, you're rewiring things and stuff like that. So it was kind of, I would say, a bit shaky, maybe technically possible, but if you really do that, then kind of stuff breaks a little bit here and there because it was not really built for that, with that in mind. Right?
Well, and I think, I mean, at least from the IntelliJ perspective, I still have to do a reload. I still restart the IDE. And then I think for the Eclipse, I remember having to restart on some things, but I unloaded plugins in particular.
I think that's still the way people use Eclipse. So they install additional extensions, and then they press restart, and then they get these additional extensions installed. Technically, it would be possible to do that dynamically in runtime in many cases, but I think it never really made it.
And I think this OSGI foundation, which encouraged or fostered modularity, I think that was really good because, of course, later on, you would come and repurpose the support for Spring and extract that out into this language server. What was that? What I mean, when
Yeah,
did you?
that was not really that. I think that was not really based on the modularity of OSGI or anything like that. It was really the idea that in the old days we built everything into Eclipse plugins and used all the API that Eclipse gave us to integrate
Right,
with with the panels and with the editor and with the autocompletion and things like that. And we always thought about what would happen if we want to support a different IDE, or what would happen if we would like to run the thing in a browser to offer people like kind of cloud-based coding environments that we were investigating back then, and implemented some prototypes about, oh, what would happen if you build a browser UI, an editor in a browser? Would that work? Yeah, that works. But you cannot really build the kind of the Java autocompletion or the Java compiling and parser again in JavaScript and put everything into browser. That would be weird, right? So
right,
we thought about what would it mean to kind of run the language logic and the functionality at the back end, and just have the front end using kind of the editor features, squiggly lines and things like that. But if you press auto completion, you would go back to the server and ask the server for the language features. That was the
right,
idea back then. And then VS Code came along with the language server protocol with the, hey folks, we basically did that, but kind of 10 times better than what we thought about. That makes sense to adopt that. So we adopted that technology, because when I saw that, and I think when the team saw that, it felt like, oh my God, this is exactly what we wanted to build and what we thought about, but already built and specified. So let's go down that path. That makes super sense.
right.
So it felt to us like, yeah, we knew this is the right architecture to build language tooling for the future. And that was a little bit kind of weird because Spring is not a language, right?
Right.
So Spring is a framework, and the protocol was really built for languages, so that you can add additional languages to your environment. And so we
Right.
thought a little bit about, would that still work, and does it still make sense? And it turned out, I think it still makes sense to do it.
Right.
Sometimes it's a bit kind of, it's not very close to the spec, but
Right.
we're kind of misusing maybe here and there the kind of little things here and there. But you
Well,
could
but
probably build all the stuff, and then we more or less rebuild the existing Spring IDE functionality, at least those parts that we thought might be useful in the future, into these kind of headless version that could run as a server behind the scenes as a language server, and offer the functionality to the outside world through this protocol.
was that work? Okay, I guess my original thesis was that by designing for modularity with OSGI, you had the ability to isolate these components and extract them out. And you're saying
Yeah,
you had
no.
done that work just to be portable in the first place, and it was already there, whether you were doing OSGI or not. Is that fair?
Yeah, I think we did a lot of these kind of modularity in terms of based on OSGI, based on plugins, in terms of we wanted to structure our tooling
Right.
and our code base, like every other kind of code base that exceeds a certain amount of classes or whatever. You need structure, right? You need
Sure.
modularity. You need some kind of architecture to make it able to kind of develop that in 20 years from now
Right.
continuously, and to keep it flexible and so on.
Right.
And that was kind of where OSGI gave us a lot of additional features and additional constructs to do that. But it was not these kind of thinking about what parts of the tooling can we strip out and put into a back end, a headless thing that runs against the language server protocol. Was a totally different effort.
Okay. Oh, interesting. Okay, that is interesting. But okay, so you had this well-structured code base anyway, and you were able to then extract that out to a language server.
Yeah, but we actually rebuilt a lot of stuff as well. So
Sure, but I mean, I'm imagining that the stuff you had to rebuild was UI and framework integrations with that UI. Is that fair? Like I imagine the
mm,
intelligence for looking at code is reusable. But
Yeah, there was one part, and the other part is that we rethought a little bit how we interpret Spring projects. I think in the Spring
oh,
IDE back then, the underlying architecture was really built around. It was kind of something like what the Spring AOT stuff is doing nowadays. It
right,
was really built like in the IDE, in the JVM of the IDE, you start up and load the classes from the project and start it up a little bit and use the Spring framework to build the bean definitions and all those kind of things, but not really instantiate the beans of the project and so on. And then
right,
use this information to present to the user what are the beans in your project and things like that, right? To get the information about the Spring information about the project.
right.
And that was really cool because it was kind of reusing a lot of the functionality of the Spring framework and was therefore very close to what the Spring framework would actually do with the source code. But at the same time was also kind of quite tricky because you need to take care of, not kind of really instantiate the beans and not really do stuff. And you were loading types of the project into the JVM of the IDE.
Oh,
And you had to redo all of that all the time because when people change the source code, you need to redo that. And it was kind of sometimes a little bit slow. So we put in a lot of optimizations to make it fast and things like that. So it was really tricky. And
right.
when we moved over to the language server protocol architecture, we thought about, do we want to continue on that path? Because we struggled with that quite a bit. Or do we want to look at that from a fresh perspective? So we looked at that from a fresh perspective and thought we should kind of move away from that, or we should at least try something else and try to get this information about what are the beans in your project, whatever, purely from looking at the source code, like your real IDE would do, right? Looking at source code, parsing source code, and grabbing information out of source code instead of actually sort of a little bit of running the project itself. So that was kind of another shift kind of in the underlying architecture and in the way we build the tools.
Is that why when you started doing the language server stuff, you also had these little, these, like the actuator?
The live hovers?
Yeah.
That was kind of the next feature that we basically built in.
Based on this new architecture, is that fair?
Yeah, it was based on the language server protocol architecture, but it was also based on this idea about we can look at the source code, right? We can tell you everything about the source code, or we can kind of, in the old days, start up the app a little bit or whatever. But looking at the source code might be a different thing than what is the app doing at runtime, what beans are really instantiated, right? What controllers are really active or not. So we thought about what is the best way to do that and to give people the information about what is actually happening at runtime instead of just looking at the source code. So we have these two perspectives, right? Looking at the source code, we show you everything that's in the source code. And then if you run the app, we extract the information from the real running application with the actuators and overlay that on the source code so they can see both, right? You can see the source code, what's there, and you can see what parts of the source code are active in your running Spring application at runtime and how does it match, right? Which would you usually do that kind of yourself. Like you try to think about, there are the beans, what happens at runtime, and then you think about how does it match to the source code that I see in the editor. And we try to basically bridge that gap and say, hey, we do this translation for you. We show you what's going on at runtime in your source code.
Does that?
It's very similar to what maybe some debuggers are doing nowadays. Like if you debug source code, they show you the values of variables kind of inline in the editor and things like that.
Sure.
Follows that kind of pattern.
But does that, when you're editing the source code, I guess at runtime, I guess by the time you have the ability to run the program, the source code must be valid code, right? But does that give you the ability to, let's say I've run the program, I've got information that's cached from that run, I've built up knowledge about the structure of the code because I understand what it looks like at runtime. Can you then use that to fill in gaps when the code is in a non-compiling state, for example, after a few changes? Like, is there places where these two overlapping views of the same thing enrich the
no
thing?
Not really.
Oh,
No,
interesting.
no.
Interesting.
When the app runs, we show the information on the source code. When the app does not run, the information is gone.
Right.
The cool thing about this is you can do this for multiple instances at the same time. So if you have the app running locally in your machine and you have the app running in your integration system at the same time, you could connect the IDE to both and see
Right.
the live information from both instances in your source code. So you could see, for example, that, oh, I don't know, this condition matches locally, but it does not match in the integration environment where the app is running because of some reason, right? So you can see, what, for example, what is the difference between two different instances running, because you see the live information from both apps in the source code at the same time. But it does not do the next step saying, oh, if I kind of shut down the app and I change my source code, that it sort of influences auto completion or validation or anything like that that happens on the source code level. We try to kind of keep this distinct from each other.
Interesting. Okay. Well, so you've got now this language server, and you've got this ability to extract that out and make it reusable on top. And you've described this to me before, and it still blows my mind because I think you were just alluding to this a minute ago when you said that you were doing it in a kind of a weird way. And but I think the way I remember you explaining it, and correct me if I'm wrong, you said that basically the language server that you are shipping is not a standalone language server. It sort of sits on top of a Java language server somehow. Is that true? Which is not something that's natively designed?
So yeah, it's kind of, it depends a little bit. So the first thing is our language server does not do any kind of Java language tooling. So
Right.
usually what an IDE or like VS Code is doing, right? You open a Java file and then it talks to a language server for this type of file, like the Java language server, to get auto completion for Java and whatever. And so what we do with our language server, and we say, oh, we are interested in this kind of file types as well, so we can work on Java as well. So that VS
Right.
Code says, oh, I now have two language servers for the same file, right? I have the Java language server and I have the Spring language server. And the client VS Code is then, for example, if you hit auto completion, it basically talks to all connected language servers, collects all the auto completion, and then kind of merges everything together and shows you kind of as this is the auto completion. So this is why, from a user perspective, we can basically enrich the Java editing experience with additional hover information, additional code completion, additional whatever, because the client just merges the stuff that it gets from our language server as well.
Interesting.
So that's why it feels it's just kind of, you get auto completion, but where the real auto completion comes from, some parts probably come from the Java language server and some parts come from the Spring language server, because we only focus on the Spring specific things. Right? And then the next question, if you look behind the scenes, is if we build this the Spring language server,
Right.
the only thing that we know is basically the file system, right? So we get the file system or kind of a pointer to the file from the client. How do we know about the class path and the versions and resolving types and parsing everything against the resolved class path, because it's a maven project and you have to download stuff and whatever.
Right.
And there are basically two things you can do. You can say, oh, I do this on my own, right? I take a look at, oh, is that POM file? And then I kick off Maven and do everything and let Maven resolve everything. Or I can basically defer this to the tooling that is around me in the IDE as well. So if there's a Java tooling installed, the Java tooling is probably doing all that, right? It's kind of resolving the class path and so on, figuring out what the project. So we talk to this Java language server and say, please give us the information about the project, like what is the project name and what is the Java version and what's the resolved class path. And it's mostly focused on the class path.
Is there
no, there's no standard way to do that, right? It's just our custom integration that we build.
But
then we get this information, we use that.
Did you have to talk to the Java language server team to like, hey, can you make these hooks available so we can?
Yeah. The funny thing is the actually in VS Code there are kind of, I think, 2 Java or maybe 3 Java language
Right.
tooling things available. But let's say the initial one, the Red Hat one that was built from Red Hat,
right.
published from Red Hat, that's kind of, I think, the most famous one nowadays.
Yeah.
And it was basically throughout the previous 10 years. It's built on the Eclipse technology from back then. So they took the Eclipse underlying architecture. So they run a little OCI server, they run the Eclipse plugins inside of this Java language server.
Right.
And that way, this Java language server is extensible. So you can add extensions to this Java language server if you want to. And that's what we did, right? Specifically for this Red Hat Java language server, we implement a little extension that then gets loaded by the Java language server. And that is able to kind of basically talk to us and send messages forth and back to say about a project changed, the class path changed, this is what the class path looks like from the project, and then tells us how this all looks like.
So they didn't even intend.
Yeah.
It wasn't even intentional. It wasn't done at the Visual Studio Code level. It was done just at the same level you would have done it as if it was in Eclipse.
Yeah.
Wow, that's brilliant.
But we also have a version of the language server that is able to do all the stuff on its own. So that's kind of the good thing, because it's a little bit kind of modular, right? So you can either talk to the Java language server with our extension and communicate, or if that's not around, you can start it up in a version that is standalone.
Well, okay, that brings up a good point.
That calls Maven on its own and grabs the class path and so on from Maven.
What about, I know that Oracle just released one a couple years ago. Do you support that?
No, not yet. Right? We could, and nowadays we could it in two ways. Actually, we could say, okay, in that case, you start our language server in a standalone mode, so it does everything on its own. Or we could build this little extension that we built for the Red Hat Java language server. We could build something like that for the Oracle language server as well.
Interesting.
And basically kind of talk the same messages forth and back, but we haven't done that yet. Right? So
okay, possible,
but we haven't just done it.
I don't know. I mean, if somebody asks, I'm sure you'll,
Yeah. I think there was kind of a few years ago when that was kind of a new thing. Someone was already asking for it and saying, "Hey, can we do that?" We gave advice and provided all the information that was necessary, but I'm not sure whether that went anywhere.
Interesting.
Yeah, it was interesting. Yeah.
Very. I mean, I love the pluggability, but it is kind of the Visual Studio Code ecosystem feels like the Wild Wild West sometimes, because you've got this new approach to layering things that isn't really standard. So that layering would not work for a pure play language server. It only works because they both happen to be Eclipse plugins before, which is interesting. Maybe that's a thing they should extract out and hoist into the language server protocol as a way of layering.
But it's not really. It does not really depend on, because we inherited this Eclipse history. It's more like the Java language server allows you to add extensions, right? And as soon as you get that, so our language server has nothing to do with Eclipse anymore, right? There's no OSGI, there's no plugins, there's no runtime. It's just a language server as you would build it for VS Code. And that talks kind of messages that you can send with the language server protocol forth and back. And on the other side, there needs to be someone who understands our messages, and this is done as an extension to the Java language server. And the way you do it for this Java language server is to do a little OSGI bundle that you plug in to that. But that's very specific to how that is built.
But would you have written that same integration in Eclipse or in some other experience, or is it just for the language server?
Oh, actually, we so we still ship a version of the Spring Tools for Eclipse.
Right.
And how we do this nowadays is it does not contain anything from the old Eclipse plugins anymore. Instead, it contains the same language server that we ship for VS Code, and integrates this language server into Eclipse. Right?
Oh, that's brilliant. And so their primary vehicle by which you deliver the plugin is through the language server, and now Eclipse is the foreign host. Oh, that's interesting.
Yeah, Yeah.
And does that,
And
so this,
for that, of course, we had to build this little extension that talks from the environment that gives us the information about the what is the
the actual
project or what
Java,
is the class path. We need to put that into the Eclipse IDE as well. There's a little extension so that our language server can talk to either the Red Hat VS Code language or Java language server,
right?
send messages around and get the class path. Or if it's running inside of Eclipse, it gets the information from Eclipse, from the Java tooling inside of Eclipse.
Oh, it's so funny because so originally it started off as Eclipse is the main thing, and we also have this language server packaging of it. Is that fair? And now
Yeah.
it's the other, now it's been completely inverted. Oh, that's
Yeah,
funny. That's cool.
And the cool thing is, we now, as kind of a very, very, very new thing,
right.
we now support Claude Code. So we have an extension for Claude Code.
What,
we can dive in that into a second, but the underlying technology is also kind of behind the scenes. It runs the same language server, right?
wow.
But in the standalone mode, so it can kind of, because there's no Java tooling around, right? It
Right.
can find out stuff about the project on its own.
So language servers are, now that's for people who don't know, language servers are, yeah, exactly. I'm feeling this. I'm having the same exact response here. Wow, it is mind bending, like what you just said. Language servers are a protocol. They're a way for Visual Studio Code, which is a language, which is a tool built on top of Chromium in JavaScript, not the good kind of JavaScript that you can do in Java 25, where you can just run a Java program as a script, but instead the bad kind that you would have gotten from something like Node. And so Chromium and Visual Studio Code, they don't speak Java natively. It's not it doesn't speak C++ or .NET or Python or Ruby either natively. It's completely different. So one of the genius things that in my mind, the same team that worked on Eclipse took forward into their effort when they built Visual Studio Code was to design this plugin system where basically you have kind of an RPC or IPC kind of between the plugin that does the analytics and does the work of the language server basically, and the host. And so it doesn't matter. You can write the .NET developer wanting to write the plugin for .NET can do so in .NET as long as they speak the same language server protocol. Is that fair?
Yeah, absolutely. Perfect.
And,
exactly.
And that is different from the Eclipse case where you had everything the same shared global, JVM. And that's why you need these extra Herculean efforts like OSGI to carve out process space, grants or whatever, and to share and co-locate duplicate classes in the same JVM and so on. Does having a language server make it much easier to unload plugins, right? Like
I think that's not part of the language server protocol itself. I think that's part of the way VS Code
is architected,
deals with extensions in general. So you can write extensions for VS Code,
right?
In TypeScript as well. Like forget about the language server. Just as you would have done in Eclipse, you write an extension for VS Code in TypeScript instead of Java, and you plug that in. And the way VS Code runs those extensions is in isolated processes and hosts.
Right.
Anyway, so all these extensions run in isolated processes. And then if such an extension calls out to a language server, there's a language server runs in an isolated process as well. So you can just shut down the processes, basically. And then they are gone.
Right.
They're not running in the same V8 engine, or they're not running in the same process environment or anything like that, which makes it a lot easier and a lot more stable.
Right.
Because in the Eclipse times, right, when someone wrote a bad plugin, or the plugin was kind of shaky, buggy, whatever, it could basically drag down the whole IDE because it was running in the same JVM, and that does not happen in VS Code anymore, because if the plugin behaves badly, it's just the process that behaves badly, it does not affect everything else.
Which is, I would think that's a very good thing, right?
Yeah, absolutely. Yeah. I think that's one of the things that they learned, right, from doing all this stuff on Eclipse. They learned about, what are the good things, what are the bad things, and for the bad things, they said, we should probably do it differently this next time, right? And they did.
Right.
So pretty impressive.
And I think I think the original Eclipse architecture made sense when RAM was at more of a premium, and we just trusted people to be on their best behavior. But now, I mean, Google Chrome showed the world, right? Each tab can have its own process space. So if that's
Yeah.
true, then why can't each plugin, I reckon most people start more tabs than they do process plugins rather. So why not? Okay, so you've got a language server, you've got a plugin for every experience. I've used it from NeoVim, which is quite pleasant. And you've got it. I even blogged how to set it up with Emacs. Like, actually, I wonder when I did that. I got the language server stuff working with Emacs. Let me see. I did that before the virus, I think, so a long time ago.
Wow.
Well, maybe it's not so easy to find. Oh well. Anyway, I think it's just really interesting. You've got this proliferation of plugins now by writing it. I can't believe we're at a place where there's a sort of de facto standard now, but basically the result has been now that there's no reason you can't have nice support for writing Spring-based applications. Is there, what are some of the what are some of the new things in that, in the feature set for working with Spring applications before we get to the next application of that plugin model, which is the MCP stuff? Or is there anything new that we should know about, because it's been a while since we last talked in the
Oh,
pure
I think
fledged feature category?
we do this usual stuff of looking at what are all the Spring projects doing and trying to
Right.
support it in the best way possible. So one of the things, for example, that we added lately is in Spring data, you can now have these type safe property references instead of just having strings in queries or things like that to refer things.
Yeah.
And of course, you want refactoring for that, right? So you want to kind of let the IDE, and that's what we did, right? Let the IDE identify where you use all these strings to identify properties in your Spring data code,
Right.
and highlight that, and then by one click, refactor that to the type safe property reference versions that exist nowadays, for example. That's, for example, one thing
That's
that we
so
worked
cool.
on. And things like that, right? We do a lot of things like that along the way, and then probably kind of tons of other things in that space. But we, of course,
so
also
cool.
looked a lot about kind of additional stuff and new stuff in the AI space nowadays, right?
Well, that's okay. So that's the next thing, right? Which is
Yeah.
what I think a lot of people are using. They want the intelligence that your tooling can give, but they're not, the consumer isn't necessarily just a person. It's an agent, isn't it? It's going to be.
Yeah.
So what do you got in that space? That's the big
Yeah.
question.
So what we did as kind of the initial thing is we enhanced the language server that has all this knowledge about Spring projects and analyzes everything and indexes everything and has all these kind of, say, smartness about Spring. We enhance it that it also offers an MCP server to the outside world.
Really?
So on the one side, it talks LSP to the IDE, and on the other side, it talks MCP to an coding agent, an LLM, or whatever you connect to it, so that this coding agent can use the smartness of the language server that knows everything about the project from a Spring perspective to kind of improve token usage, to be smarter, to be faster, to create better Spring code or whatever. So that's what we integrated into the language server. So whenever you start up the language server, for example, let's say you use VS Code, you install the Spring tools into it, you can enable this MCP server. And then if you use, for example, Copilot, or you use Claude, or you use whatever coding assistant you use in
Right.
VS Code, you can connect that, as long as it supports the MCP protocol, which I think most of them do. You can connect it to the Spring tools MCP server that runs in the same IDE space, and then it knows everything about the project and can ask the MCP server to give information about the Spring version that's used and the beans that are there and the resolved class path and things like that. So instead of giving everything to the user via the LSP protocol through the editor, we also try to give this information to the LLM via the MCP protocol, which is basically that. And then the next thing on top of that is that we ship the language server as a plugin for Claude Code. And then basically it only offers the MCP endpoint to Claude Code, so that if you run Claude Code from the command line or whatever, the Claude Code can use the Java smartness of the language server as well to improve its kind of knowledge about the project, token usage, whatever. It does not need to find out what is the Spring version that is around in the project and things like that. And one of the cool things, for example, is the language server has a validation for the project that validates Spring versions, right? So it looks at your project, says, oh, you're using Spring 4.05, and it tells you, no, you should not do that. There's 4.07 out there, or there's 4.10 out there. So this is kind of a validation that you see as a user in your IDE, right? Little kind of squiggly lines and problem views or whatever. But we give the same diagnostic to the LLM or to Claude Code in this case. So Claude Code can figure out what is the latest version of Spring, what is the version that you have in your project, is that outdated or not, without trying to figure that out on its own, without going to Spring.io, without searching for something, whatever. It just gets the information directly, for example, from the MCP server, from the language server behind the scenes, more or less.
Wow. This is like, oh man, so this is a different world. I mean, it still makes my mind boggle to think we're able to feed. You're writing code for code now, like your consumers.
It's interesting because in the early days, right, when you did these IDEs and we implemented language servers and IDE plugins and whatever,
right?
So the whole goal that we had in mind, or that you always had in mind, is to make the user more productive, right? To keep the developer in the flow,
right?
To make him not leave the IDE, right? To make him not leave the editor. You can stay in your code. You don't need to look up the documentation to find out what's the method name, right? You don't need to look up the documentation to find out what is this method all about, or what does this parameter mean, because we give you hover information, we give you auto completion. We give you squiggly lines when the syntax is broken. You don't need to call out to the compiler and wait for it, whatever. Right? So we kept you in the flow, keep you in the editor as a developer. Right? And now this kind of shifts a little bit. So we try to keep the LLM, the coding agent, in the flow, right? So that the coding agent does not need to go out and build the whole project and wait for the compiler output and interpret that. It can get this information right away, right? It does not need to search on the web in a weird way to find the Spring version. It gets the information right away. So it's interestingly, it's following the same principles, the same ideas, the same motivation, but the user is not the developer in the editor. The user is now kind of the coding agent looking at your files, right? Which is a bit weird.
Isn't that weird?
And a bit kind of, you don't really exactly know yet what to do in this space. It's a lot of experimentation and the coding agents they change all the time and things like that. So they get a lot smarter with every model. We all know that, right? Every week.
Right.
But so it's always a bit kind of, I think it's at the very early stages and at the very beginning. So, but it's interesting from a language tooling perspective. You can try to do, and we try to experiment in this space and do it with these MCP server and the Cloud Code plugin that you can use.
So, which ones? You don't have to tell me, but have you had better success with some models than others? I mean, if you can speak to that.
Yeah, so I use a lot of these kind of Claude models, but we haven't really done a lot of investigation about comparing models or seeing which model works better.
Sure.
or how you need to talk to which model to. So sometimes I know that kind of Claude Code or other coding agents do that, right? They figure out which model did you select, and then they change the underlying system prompts and the underlying user prompts and the underlying context in a way that this model understands better than another model.
Right.
And we don't do that now. We don't have the expertise in that yet.
Okay.
Maybe in the future, I don't know, but I don't know yet.
Interesting. Well, okay. I'm really excited to see. I mean, I think giving these tools better, because one of the big problems with we've got this situation where because things started with Python, the tooling tends to be a little bit better when it comes to agentic coding, tends to be a little bit better in Python. And I think giving the agents more visibility into what the Java process is doing will help, claw back some of that lead there, because we have more information that we can provide these agents. We have a type system, we have all this amazing stuff, and so I think just tools like this are just super valuable. It'll help make these agents. I think these these agents have been trained on Python code because they were written in Python, right? And so that's what they knew. And but that doesn't mean that they understand Python better. It just means that they've looked at more code. And it's not easy for them to make conclusions about Python code because there's no types. There's type hints now. And the same is true for TypeScript and JavaScript. There's type hints in TypeScript, but not necessarily JavaScript. And so if it's a brand new thing and we're looking at just pure play Python and pure play Java, in theory, Java should be the better outcome because we have more information we can feed to these models. But through the just sheer amount of code that's been swept up into these models, I think they've got a little bit of an advantage here. So these tools, making these models, amplifying their intelligence, augmenting their intelligence, as you're doing with these MCP services, so valuable. Give them that extra insight so they can make better decisions. So I can't wait to try it out. I don't know. I just feel like this has been so interesting. I know I can consume this stuff from Claude Code, for example. One of the things I've seen is kind of going the other way. And Cursor, obviously, Claude Code, Cursor, they're in that agentic first sort of workflow, category. But for example, is Eclipse? Is there like an AI model based editing experience inside of Eclipse these days, or?
Yeah, so the stuff that I know is that the Copilot team, so the folks that build the Copilot integration for VS Code, they also do I think great Copilot integration for Eclipse. So if you use Eclipse, you can install the Copilot plugin, and that integrates nicely into Eclipse and gives you basically the same or very similar experience in the editor and with this chat window and in the integration. And if you install the Copilot plugin into the Spring tools, or have both installed in Eclipse, right? The Spring tools and the Copilot thing, they also kind of automatically connect to each other so that we configure the MCP server for the Copilot plugin and so on. So you don't have to do anything yourself. It just figures that out that, you have both installed, so we should kind of let them talk to each other with these MCP protocol. So that the Copilot integration Eclipse is already kind of knowing about the Spring smartness and gets the information from the Spring language server that's running behind the scenes.
We live in just the weirdest time. Good question here from the audience here. What's the hardest part of exposing Spring-specific context to AI coding agents through MCP, like context, quality, latency, or hallucinations, etc.?
I think exposing the Spring-specific context to AI is not that difficult because we inside of the language server, we know all that, right? So we have precise information about the source code, and we only infer information from the source code and give this the coding agent via the MCP protocol. whatever the coding agent is doing with that information, we basically have no real influence on. So we cannot really influence if it's kind of doing hallucinations on that, or if it's doing other stuff. Or sometimes it's a little tricky to kind of make the coding agent actually use the MCP server to get this information instead of trying to figure this information out on its own, right? Because if the MCP server would not be around and the tools would not be around, the coding agent would just try to figure everything out on its own, right? And looking at text files and searching the web or whatever. And sometimes you need to kind of poke it a little bit and say, hey, use the Spring MCP server, use the tools if you need information like this.
Right.
And we experiment a little bit with the description of the tools to make it really easy for the coding agent and the LLM to identify the right tool and use the right tool when it makes sense. So that's kind of a bit of a tricky part, I would say. Because sometimes we have the tools around and we can do everything, but then the agent decides to not call it, right? And say, hey, why are you not calling my little tool? It's so nice. It would give you everything you want.
Right.
But so sometimes you need to kind of nudge it, which is in, for example, in the Claude Code case, a little bit easier because you can add these kind of so-called skills to Claude Code, and inside of these skills, you can basically really explicitly teach the coding agent to, oh, if you want to, for example, create a new Spring Boot project, do this, right? Or if you want to kind of get diagnostics about the project, do this, right? Call this tool and get the information that way. It makes it a little easier, at least what it feels to me. A lot more reliable, but yeah, that's kind of a challenging part, I think.
Interesting. This is super interesting. My friend, I'm very excited. Where can people learn more? Where can they try this out? What's their next steps?
So the main website for the Spring tools is spring.io/tools, where you can download the Eclipse distribution, whatever. You can find the GitHub repository from there as well, and you can find all the releases and all the documentation about the releases in there as well. The Claude Code plugin is a little bit, I would not say hidden, but it's a little bit harder to find. But if you look at there's a kind of a Blue Sky and Twitter account for the Spring tools as well, where we post information about the releases and hints about where to find everything. But the best place to contact the team, for example, if you have questions or if you find bugs or issues, is to find an issue on GitHub on the project. So yeah, I think those are kind of the best places to find the things.
So cool. My friend, are you on the internet, and if so, do you wish to be found? And if so, where can people find you?
On Blue Sky, on Twitter, on LinkedIn, you can find me, I guess. Yeah.
Blue Sky. Oh, nope. I searched. Apparently, there's something called a Martin Lippert. That's different from your name. Here we go. There we are. There's and I'm sure you can find the others.
Yeah.
From there. Martin, my friend, this has
Awesome.
been amazing. Everything you're doing is just so cool, and
Thank you.
I'm seeing more and more people use the Visual Studio Code stuff all the time, and it was very interesting for me to. Just this year, I've noticed several times it's obviously starting to take off. So well done as always, and thanks for.
Thank you. Great to hear.
Hanging out tonight.
Yeah, my pleasure. Thanks for inviting me. Always great to be on this amazing podcast.
My pleasure's mine. And to all of you, thanks for hanging out. Have a wonderful, wonderful evening, morning, afternoon, whatever. Bye.